Hello everyone. So in this session we will learn some basic concept of differential equation. Okay. So what is our aim? Our aim is to study some basic concepts of differential equations. Okay, so first recall how to solve this equation. 2x plus 1 is equal to 0. How to solve? Let's say equation number 1. So I hope all of you must know how to solve this equation. Now the question is, x equal to minus 1 by 2 a solution of this equation 1? What is your answer? Yeah, yes, it is a solution, because when you substitute this value minus 1 by 2 in the place of x, you are getting the right hand side, which is 0. So that means this is a solution of 1, right? Good. Now we will move to something different. Now see, consider the equation of this form. 2 okay equal to 0. So let's say 2, equation 2. So now we will consider this equation. I hope you know what you mean by dy by dx. That means if you have a function y, dy by dx is nothing but derivative of y. So now you have the equation of this form. So now the question is that, even before moving to the question, can you observe what you are observing? Maybe I can use this side. So from the equation 1 and the equation 2, what you are able to observe? Yeah. So in the place of x, you have dy by dx, right? So that means, can we say its solution, or can we relate the solution of this one and the solution of the equation 1? Solution of the equation 1 is x equal to minus 1 by 2. So here, as of now, we don't know what is solution. So solution of the differential equation means you need to find the function y. If you put the function y here, take the derivative and substitute, you will get the right hand side, right? Like what we did. Now this is the solution of this one. Now we already know that x equal to minus 1 by 2 is a solution of 1. And 1 and 2, there is a relation, you are able to find it. So can we relate the solution of 1 and solution of 2? So what could be the initial guess? See, in the place of dy by dx, x was there, right? x was there. So that means we can say that by dx is equal to minus 1 by 2. Can we conclude that this relation is valid? Yeah, because we are just treating this as a x, so 2x plus 1 equal to 0. So that means since x equal to minus 1 by 2 is the solution of this one, we can directly relate it as this, dy by dx equal to minus 1 by 2. Now, can you find what does it mean? That means that derivative of the function y is minus 1 by 2. Now the question is, can you find a function y whose derivative will be this one? Can you find y such that so dy by dx equal to minus 1. What will be the initial guess? What you can make what function you will make the derivative will be minus 1 by 2, or to be more simple, the function whose derivative is 1 is what? X. Now you want minus 1 by 2. So what could be this y? Initial guess? Y could be? Yeah. Minus 1 by 2x. So is this the... Now the question is, it is clear. 3. So 3 is a solution of 1. That is confirmed. Now the question is this the only solution? Is this only solution? Yeah. No. Because if you add some constant also, this will work, because we know that derivative of the constant function is 0. That means you can always put your solution could be plus 1 or plus 2 or some constant k. Right? So this is the solution of this one. Okay. Now observe what we done. You started with some equation. For that, this is a solution. Now you have some differential equation. I didn't define what is differential equation. For the moment, you can take it as this is a differential equation. Differential equation, we will define it properly. So for the simplicity purpose, a equation involving derivative is called as the differential equation. Okay. So for this differential equation, we are able to relate it with this one, and we finally got the solution. So this is a solution of this differential equation, right? Okay. Done? Yeah. So now what we are able to do, and before that, what is this one? What equation this is? Yeah. So note, what type of equation, what we are calling this equation as, and here also you have equation. The equation 1 is called as algebraic equation. Means it is not the general form, but it is one of the algebraic equation. Okay, this we know. Now the equation 2, this one is called differential equation. Okay, so this is the differential equation and this is the algebraic equation. We know how to solve algebraic equation. right, previously. Now through this way, can we conclude something? If you know how to solve algebraic equation, then can we say that we know how to solve differential equation also? Yeah, because we are able to find the relation. So this is our differential equation. We are able to find the relation with the algebraic equation, in the sense that corresponding algebraic equation, then we are able to get the solution. So that means if you know the solution of the algebraic equation, then you can find the solution of the differential equation. Okay, now the question is, okay, questions. Now the questions are, whether all the differential equation will have the solution. This is question number 1, whether all the differential equation will have a solution. Now the second question is, if a differential equation has a solution, what are the possible questions we can raise? You have the differential equation, it has a solution. What are the possible question one can raise? Whether the solution is unique, that means it has only one solution, or it has multiple solution, or that differential equation always can be solved through this comparing with the algebraic equation. Is it possible? So that are the 3 questions it will come, right? So what are that? Is it unique? Second question, always algebraic equation will help. Okay, so these are our questions. Now our main focus is that this is unique or not, that we are, for the moment we will skip it. Our main aim here is that we want to study this one. Like, of course, this we will see that always this algebraic equation will not help you to find the solution. Now the question is, for this is answer is no, always algebraic equation cannot able to find the solution of this one. But the question is, when that algebraic equation will help you to find the solution of the differential equation. Okay, so that is the question. So it over here. So yeah, so always this algebraic equation will not help. Now the question is, when this approach means algebraic equation approach will help. Or in other words, it is not only the approach algebraic equation, there may be some other approach. So when that approach will work. So now you have, if you have many approaches, when a particular approach will help us to solve the differential equation. So this is the question, right? So in order to study that, what we need to first classify the differential equation. For what type of differential equation we can find the solution, right? I mean, we can find the solution in a particular form. So once you classify the solution, once you classify the differential equation, then you can classify its solution and find the method. So to answer this, first we will classify differential equation. Once the classification of the differential equation done, classification means you have many differential equation. For example, I will give some example, then you can maybe realize it. What I will consider the same example what we consider 2 dy by dx plus 1 is equal to 0, or d squared y by dx squared So this is also a differential equation. Why? Because differential equation means it is an equation involving some derivative. It could be first order derivative, second order derivative, or any other derivative. Okay, or else sine okay, this is done, or even more general you can put it. Okay, so now consider this one. Now there are some differential equation. First you need to classify, then we can say that for this particular class or any equation of this type, in the sense ax a dy by dx plus c, any equation of this type will have solution of this form. Like that, for this type we will have some type, solution will be of some type. Like that we can classify. So that means we want to, in order to classify your solution, you will first classify your differential equation. Okay, so in order to classify your differential equation, you need to introduce some definition or some names for this differential equation. So that we will do. So initially, by looking at this differential equation, first how we can classify, what could be our guess? You have the derivative, right? So here, what is the order of derivative?
1.
But I didn't define what is order of derivative, right? So the order of the derivative is nothing but highest derivatives order used in the equation. Okay, so that means here only one derivative dy by dx is used. So that means order of the derivative is 1. I hope I no need to write this, what is the definition clearly. So order of the derivative means highest derivative used in the equation. So that means here order is 1. So this is one classification. Now here what is the order of the this differential equation?
6.
6. Okay, why it is 6?
Because derivative square power is 3.
Okay, so okay, let's recall the definition. Definition says that highest order derivative used in this. So here what is the highest derivative used in this equation?
6.
Highest derivative.
D square y by dx square.
Okay, so d squared by, this is the highest derivative, right? Means second derivative used. Okay, so you have second derivative power cube. So what is the definition of order? Highest derivative used in the equation. So highest derivative used is what? See, you have something power cube. It doesn't mean that this, for example, you have x cube plus 1 equal to 0. Okay, so here what is x? X is a variable. So you are assigning some name to this variable. Okay, so even if you write x squared plus 1 equal to 0, what is variable here? X. So definition of variable is nothing but something which appear in this equation. Like x plus 1 equal to 0. So what is variable? X. In the same way, how you are thinking variable, in the same way you have to think, not in the same way, but you can think it in that same way, that what is the highest order derivative. So here what is the highest order derivative?
2.
Yeah, 2, because it is of this form, x cube plus 1, like that. So here that instead of this variable you have d squared y by dx squared. So that means highest order used in this equation is 2. So order is 2. Okay, now here what is the order?
1.
Yeah, 1. And here the order is
1.
yeah 1. Now what we done, we just classified one classification we done. What is the classification? We used some definition that order, then we classified that among this what are the equations are order 1 and order 2. Okay, so now order we done. So through this what you are able to do for order 1, what are the equations here? Order 1, 1, 3 and 4. So now we classified these three equations are comes under the order 1 differential equation. Okay, so now what are the equations of order 2? Yeah, only equation 2. So this is of this one. So now we are able to classify into two categories. One is of order 1, order 2. Likewise, you can classify into order 3, order 4, order 5 if it involves the highest derivative 3, 4, 5. So this is the one way of classification. Is there any other way we can classify it? Yeah. So here you can observe it like as we said over here, x cube plus 1. If suppose you have the polynomial, then we are defining to classify. In polynomial, this x is a variable, and what is this 3?
Is a whole power.
Yeah, means we are in, suppose you have the polynomial like this, a naught x, a naught, a1 x, a2 x terms. So these are constants. And what is this? Here 1, here 2. What we are calling this one? Do you remember?
Power.
Yeah, power, but in a formal language, we will call this as a degree. So this is degree 1, here degree 2, like that. So for this one, so you have the polynomial p of x, the highest degree present in the polynomial is called, highest number, what I can put it in, highest power present in this polynomial is called degree. So likewise, here also you can use the degree. Okay, what is the degree definition in differential equation? For all the differential equation, you cannot define what is degree. But if the differential equation is of polynomial form, if dE is of polynomial form, then we can define degree. Then the degree is highest power of the highest derivative present in dE. See, the most important thing is that first of all, this given differential equation should be polynomial of this form. For example, this is a polynomial, means if you put instead of this one some x, it should look like of highest derivative present in the differential. First you find the highest derivative. So here the highest derivative is dy by dx. And what is the, no other option here. So what is the highest power in this one? Only 1. So that means for this one, degree is 1. Likewise, you go to second one. Is it in the polynomial form? Yes. So you have something dy by dx, it is, you can consider as squared. It is in the polynomial form. Now degree is highest power of the highest derivative. First if you go to the highest derivative, it is the highest derivative, and you found the highest derivative d squared y by dx squared. In this, what is the power? 3. So that means here the degree is 3. Okay, now go to here. and find what is the degree over here. What is the degree?
1.
Why it is 1? First you need to follow the definition, then you have to find this one. What it says, if the differential equation is of polynomial form, so polynomial, it should be of the polynomial form, then you can say sine, whether is sine of x, it is of this form, sine x. Sine x is polynomial? No, it is a trigonometric function. Sine x, cos x, tan x, these are all trigonometric function. So we cannot consider this as a polynomial. So that means here we didn't define anything because our definition is valid if the differential equation of polynomial form. So that means here you have no degree. No degree. And this one?
1.
Which this? This is 1. Why it is 1? Is it polynomial? Polynomial means what? Like it should be of a0 x, a1 x, a2 x, like this. But here you have like this. Now can you say it is 1? No. But sometime what happen? This polynomial may not appear directly. For example, you have the equation, maybe 5 I will take, this dy by dx power 1 by 3 plus 1 is equal to 0. So this is your differential equation. So can we define degree here?
Yes.
Why? Is it polynomial? Polynomial means it should be of a0 plus a1x plus a2x squared, like that it should go. Means all are integer, 1, 2, 3, right? But here you have 1 by 3. Can we do something in this differential equation and make it polynomial? What we can do? Maybe I can rewrite this as dy by dx power 1 by 3 is equal to minus 1. This is same as this. Now both sides I can take the cube. If I take cube, what happens? Dy by dx is equal to minus 1 power cube, right? Now is this the polynomial? Polynomial means you can put it in this side also, like minus 1 cube will come this side. Now you have x plus some number. That means this is a polynomial. Here you can define the degree. So what is the degree? Order is 1. Degree is highest derivative
1.
power 1. So here the degree is 1. Oh, sorry. Here order is 1 and degree is 1. Right? Likewise, for this one, you cannot, it is not polynomial form, but can you do something here so that it will become a polynomial? What we can do? First step, as before, dy by dx is equal to minus 1. Okay. Now what you can do? What is mod x? Mod x means function. Recall, mod x means it will take 1 if x is bigger than 1, minus 1 if x is less than 1. Yeah, sorry. So mod x is x if x is greater than 1 and minus x if x is less than 1. Now to make it both sides, if you put mod x squared, what happens? Both you will square it, then x squared minus will go here also x squared if x is greater than 1 or if x is less than 1. Both way it is x squared only. You are able to remove that mod. So here also what I can do, I can square both sides. What will happen? Dy by dx, okay, mod squared is equal to 1. I squared both sides. Now this is mod and square, it is unnecessary because we know that it is always going to positive. This I can remove. Now dy by dx squared is there, equal to 1. So now you can tell what is order, we already told 1. Now this is a differential equation. Is it of polynomial? Yes. You can put it. That means what is the degree of this one?
2.
Highest derivative whose power? 2. So that means here degree is 2. Okay. Yeah. Oh sorry, 2. Now we will conclude what are the things we have done. We just started with the differential equation. So for that differential equation, one can convert into algebraic equation. From algebraic equation we can solve. That was our motivation. Now the motivation was become, you want to solve the differential equation. To solve the differential equation, you need to classify it. So in order to classify, you need some definition. So firstly we wrote all the definition of all the differential equation. Then we introduced two classification. One is based on order, another is based on degree. Okay, so for order it is very simple. We just make the highest derivative present in the differential equation. And degree, you have highest order derivative and whose power, first it should be of the polynomial form. So for that we have seen some example. Now before concluding, you can think about some question. Does order always exist for the differential equation? Question number 1. Does degree always exist for the differential equation? This we already answered, it is no, because we have no degree for this one. Now you think about order always exists for a differential equation. Okay, so with this I'll conclude. You can practice some exercise problem from your textbook. Thank you.